Hi everyone. These kind of problems actually test your geometry skills more than the probability skill. So pause the video, go through the problem, try it on yourself. Now, if you have understood this particular problem, it can be solved with the help of geometry. Now, the problem says that there is a rectangular bar post. The height of the bar post is 2.4. The length is 8. Okay, the length is 8. Now, typically, this is the semicircular area which the goalkeeper can protect, and anything which is outside this within the bar post that cannot be protected by the goalkeeper. Okay, so the portion that I'm highlighting right now, if the ball comes in these region, then it will be a goal. Now, Messi, on the other hand, can hit anywhere in this semicircular range. So basically, the answer of this question will be the area of these region, which I have represented like the lines, let's call it A1, and the area of the semicircular region, which I have represented like dots. Okay, let's call it A2. So A1 by A2 should give me the answer. Now the question is find out the value of A1 and A2. Now A2 is very simple to find out, right? A2 is equals to pi r square by 2. Now r is given as 5 meter. So it is 25 pi by 2. That's the easiest thing to solve first. Now the second part is find out the value of A1. Okay. Now how can you find out the value of A1? It will be possible if you can find out the area of the rectangle, and from there if you subtract these dot dot area portion, then you will be able to find out the area of A1. So A1 is equal to 2.4 into 8 minus the area of this dot dot region. Let's call this region as A3. Okay. So 2.4 into 8 minus A3 is the value of A1. So we'll just have to solve the value of A3. Now A3 has 3 components. Let's call it component number 1. Let's call this triangular portion the component number 2, which is, let's say, C2. And the third portion is here, C3. Now C1 and C3, they are identical, right? Because it's a symmetric diagram. And the goalkeeper is sitting or standing rather in the center. So it's a symmetric diagram, right? So we can say that the area of C1 and area of C2, they are the same. So C1 is equals to C3, right? Now the thing is, we'll have to find out the value of C1 and C3 and also the value of C2, right? Now the height is 2.4 and this is the radius. I'll just simplify it over here. This is the height as 2.4 and the radius is 3. This is 90 degree. Now, if you use Pythagoras theorem, you'll find that the length of half of this side is 1.8. Okay. Now, if you have to find out the length of the entire triangle, that will be 1.8 into 2. So the area of this triangle, which is nothing but the C2, right, is equal to 1.8 multiplied by 2.4. Okay, 1.8 multiplied by 2.4. Now here you will have to find out the value of C1 and C3. If that is done, we have solved the entire problem. So we have found the value of C2. We know that C1 and C3 are equal. So we'll just have to find out the value of C1 and C3. So C1 is equals to, let's call this angle as theta. Okay, is equals to theta r square, or let's call it r1 square by 2. R1 is nothing but the radius of the range in which the goalkeeper can save the ball. So R1 is nothing but 3 meters. So it is 9 theta by 2. So C1 is 9 theta by 2. So eventually we'll have to find out the value of theta. Okay. Now theta plus this angle is equals to 90 degree, right? So let's call this angle as phi. So theta plus phi gives us 90 degree, and tan of phi. So this angle is phi, right? Now tan of phi is nothing but 1.8 by 2.4, that is equals to 0.75. It is given in the question that tan 36 degree is equals to 0.75. So we can use phi as 36 degree. We can use theta as 54 degree, right? Now, if theta is 54 degree, then we'll have to convert this into radian. So this theta here is not in degree, right? It is in radian. So 180 degree is equivalent to pi. So 54 degree is equivalent to 54 pi by 180. If you simplify this, it will lead to 3 pi by 10. Okay. So 3 pi by 10. Now, if you put the value of theta over here in this equation, you will get the value of C1 equals to C3 is equals to 27 pi by 20. Okay. Now, C1 plus C3 will be 27 pi by 20 into 2, which is nothing but 27 pi by 10. So now we have obtained the value of this C1, C2, C3, and also we have obtained the value of this rectangle. So what we'll have to do is we'll have to now just put the value of A3. A3 is nothing but the summation of C1, C2, and C3 over here, and we'll be able to find out the value of A1, right? So if we do all these calculations, we'll be able to find out the value of the answer. Now, if you have obtained the answer as option B, that is right, because if you do the calculation, it will lead you to option B. These kind of problems are the implementations of geometry in probability, and problems like this do come in CAP. Thank you, everyone.